All right. Use fundamental identities to simplify the expression below and then determine which following is not equivalent. Guys, you can also do these in your calculator. What did I tell you about these? Nobody should have missed number one. What do you mean? How can I put it in my calculator? Put it in y equals. So go into your y equals, anything in there cleared out, make sure none of your plots are on. We're gonna do sine pi over 2 minus x. Close it out. How do I put cosecant in my calculator? 1 over sine x. Looks like this. If you need to do alpha y equals, do that. I don't care. What's it asking you? Which one is what? Not equivalent. So I'm going to put my -1 in. I'm going to zoom trig because we're dealing with trig functions. Yes, it's going to take a minute. What do you notice? Is it the same? No. What would it look like if it were the same? The exact trace over. So I'm going to hold on this one for just a minute. And then I'm going to go down here and put in cosine x over sine x. Why does it look weird? So this one's not equivalent either, is it? Here's why. Does everybody see that? So you guys were questioning about that in your homework. Watch this. How do I know that it's radian mode? Let's see what happens. This is crazy, isn't it? They don't ran way too fast. Look what's happening. Look what's happening now. Yeah. What is this -1? What is it going to graph as? We already saw it. It's not going to change. It's going to graph as a horizontal line at -1, right? So that one's still going to be your answer, but I just wanted to show you that. If it's not looking right, something's weird, make sure you check radian versus degree mode. Everybody got it? So which one is not equivalent? It's going to be the first one. And to save time, I'm not going to graph the other ones. How would I put cotan x in my calculator? So if C doesn't work, what do you know about D? It would not work either. Does everybody see that? So the same. And then how would I put cosine and cosecant? Cosine x, cosecant x. How would I put that in my calculator? Cosine x and 1 over sine x. Is everybody good? All right. So number 1 should have been A. Number 2. What does it say? Is it not the same problem? It is, right? So same type of problem. How about that? Same type of problem. But I'm going to work this one out by hand just a little bit, just since a bunch of squares. What do you notice about both terms? They both have cotan, and I'm going to change it to x instead of alpha because I don't like to look at alpha. When I take cotan squared x out, what am I going to get right here? 1. When I take it out of the second part, what am I going to get? Negative cosine squared x, or you could do alpha, whatever. What is 1 minus cosine squared x?
Sine squared.
What is cotan?
Sine over 1 squared.
It's what? It's cosine over sine. What do you notice? And you're left with cosine squared x. So is this one equivalent? We want the one that is not, so it can't be this. What else is cosine squared? This 1 minus sine squared, so it can't be that one. What if it's 1 over secant? Secant is 1 over cosine. I don't divide fractions. I do what? I'm sorry, over 1. So what do you see? They're what? They're equivalent. We're gonna mark that out. This is a formula on your cheat sheet, but if you're not sure, what can I put in my calculator? Do I have to put this in my calculator? What can I put in there? What's that equal? Cosine squared x. So parenthesis cosine x, close your parentheses squared. And then I can try tan squared. Tan x squared. It is still in radian. What happened? It's not the same. So that's the one we want to choose. Once it finishes, I'll show you the other one. You could probably turn it off, but it's okay. All right. So sine pi over 2 minus x, close your parentheses, squared. There's your first one. Again, if I hit zoom trig, it'll take a bunch of that off. I just am too lazy to do it right now. What happened? Graphed right over it. So that one is equivalent. So I just wanted to show you. All right. So number 2 was C. Number 3, multiply then use fundamental identities, simplify the expression below and determine which of the following is not equivalent. So how do I multiply these? Just, yeah, just the outsides, front and back. So sine x times sine x. Positive times a negative makes a negative. Cosine times cosine is cosine squared x. What do you see? It's not B. We don't want it to be equal to that. We want it not to be equal. What can I put in place of sine squared x? Yeah, 1 minus cosine squared x minus cosine squared x. Why did I do this? Because if you look at C, it gives you that one. Again, you can put all these in your calculator. It's fine, whatever you want to do. What else? What else could I do? This is pretty easy to put in your calculator, right? Into y equals. So let's put that in. 1 minus 2 times cosine x squared. Which one of these is the easiest to put in that I have left over? Which one's the easiest to put into y2? Why is E easier? Sine and cosine, there's no fractions. We just type it straight in. So 1 minus 2 sine pi over 2 minus x, close it, cosine x. Zoom trig. I did zoom trig, so it's a little bit easier this time and not look like that heartbeat stuff. What happened? Yeah, can you guys see it? I don't know if you can or not, but it's turning red. So it's not this one because we want the one that is not equivalent. Doesn't matter which one you put in next. I would put in A next only because I only have one thing that I'm gonna have to fix for this one. I have 2. So I'm gonna try the other one. So A is 2 sine x squared minus, how do I do secant? 1 over cosine x squared minus tan x squared. What's happening? It is not equal. A is your answer. And then again, how would you put in D? 1 over sine, close all those parentheses, squared, minus 1 over tan x squared, minus 2 cosine x squared. All right, flip it. We're graphing the next one, number 4. We're graphing sine x plus cosine x. How do I do cotan? Oh, not that. Sine x plus cosine x times 1 over tan x. I'm gonna zoom trig. So we know it's loops. So what can we see our loops? What can we eliminate? A, C, and E. And then look at your first loop compared. So here's your first one. This one cuts right through the middle. The y-axis is on the left side. So which one is your answer? Nobody should have missed number 4, and people missed number 4. I think a lot of your mistakes were stupid mistakes that you were like freaked out. One reason because I wasn't here, and the second reason is just because it's trig functions. So the reason that I give you this retest, first semester grades were a lot better on the retest once I went over it again, and you guys kind of knew what you were looking at. So I'm sure that you will be fine. Next one. You should not miss 5 or 6. Should not miss 5 or 6. So all it says is take this and plug it in. You can use an X if you don't want to use theta, that's fine. You're gonna square this out. So leave this 81 alone. What's 9 squared? Tan theta squared. Tan squared theta. What do you notice about both? So we're going to take that 81 out. And we're left with 1 plus tan squared theta. What is 1 plus tan squared theta? 1 plus tan squared theta. Secant squared theta, right? Then take the square root of both. What's the square root of 81? What's the square root of secant squared? Y'all, it's that. That's it. How else could you have done it? Put this into your calculator. Put these into your calculator. Match it. Y1, Y2. So all else fails, use your calculator. Next one is the same way. So what do I do? What am I going to start with? Minus what? What is 6 cosine theta squared? Cosine squared theta. What do you notice? Leaves me with 1 minus cosine squared theta. What is 1 minus cosine squared theta? So what is the square root? Any questions? We'll come back to 7, 8, 9. I know all of you need 7, 8, 9. We'll come back to that, I promise. Okay. Go to number 10. All right. Solve the following equations. You had your cheat sheet, right? How do I solve 2 cosine x minus 1 equals 0? add the 1, divide by 2. Which coordinate is for cosine? So where is the x coordinate equal to a positive 1/2? Pi over 3. And 5 pi over 3. We'll get all of your answers. A lot of you missed that one. How many times have we done that problem? 40,000. Very good. So get your trig function by itself and then use your unit circle. All right. Which of the following is the solution? How do we do this one? Same exact way. What do we do? So we get square root of 2 sine x. You said subtract 1. How do I solve? Okay, I don't like a square root on the bottom, so how do I fix it? Yeah, that. Good job. So on the top, I have a negative square root of 2. On the bottom, I have a 2. Is everybody okay with all that work? All right, where for sine, what are we looking for? Y coordinate is negative 2 or negative square root of 2 over 2. The y coordinate. 5 pi over 4 and 7 pi over 4. 5 pi over 4 and 7 pi over 4. What's your answer? Now, out of those questions, I get 1, 2, and 3. Use your calculator. Make sure you use that. But from 4 to 11, should we have missed those? Probably not. Is it right better now? 4 through 11. All right. 12. What's it say? From 0 to 2 pi. So all that means is change that window 0 to 2 pi so you're only looking at those values, or make sure that you don't go any higher than what? 2 pi is, yeah, do any of these values go higher than that? So it really doesn't matter. So what we're going to do, it says use your calculator. So in y1, we're going to put this side, sine 2x plus 1.5 cosine x. The other one we're going to put in 0. I'm going to go ahead and zoom trig again. The other one will graph the x-axis. So we just need to figure out where it's at. Which ones do I look at? Do I care about these? No. Why? They're negative. We don't want that. We want 0 to 2 pi. So we're looking at all of these. So second trace intersect. Go to this very first one. What do we get? Which one is that? So I don't have to find all of them. I just have to find one. If I had to find another one, second trace intersect, move over. Hard problem? Do you understand what I'm saying? But it's not as hard as you're making it out to be now that you've seen it and we're going to go over it. Yes, if you got an 80, I would like for you to go a little higher. 60% of your grade. Okay. That way, if you mess up on another one, you have some wiggle room. All right, what about this one? The monthly sales S in hundreds of units of baseball equipment for an internet sporting goods site, sorry, I can't see, are approximated by that equation, where T is in time and months with T equals 1 corresponding to January. Determine the months when the sales exceed 7,700 units and any time during the month, anytime during that month. Okay, be careful about this because what does this say? So what are we going to set this equal to? What? I'm pretty sure you're saying it. Say it out loud. Thank you, Colson. I appreciate it. How do I solve this equation? Put it into y equals. Anything like this, left side NY1, right side NY2, or other way around. 60.1 minus 43.9. Cosine, we're still in radians. Pi x over 6, and then underneath is 77. I'm going to zoom fit because 77 is a huge number. Okay, so I want to fit it to my screen. So go down to zoom fit. There's the first one. There's the second one. I have two solutions in the positive. Why do I want positive? Because we can't have negative months. Everybody understand that. It's got to be positive. Second trace intersect. I'm going to go over here. So we have 3.75. It says, when do they exceed 77? That means above it. So this whole curve is above it. This other side really doesn't matter, but we're going to do it anyway. I mean, yeah, we'll talk about it. And 8.24. If T1 is January, when is 3.75? When is 8.24? Which one's your answer? What's up? Any questions? So not too bad. This would be the part that I feel like you would mess up on, because I could see you missing 13. So if you miss 13, that one, I get you. All right, flip it over. Well, you should stop doing that. You should stop doing that. The only reason you don't round is because it says anytime throughout that month. So if it wouldn't have said that, if it said, you know, it had to be at the beginning of the month or something, then you would round. You should get out of there. It's a scary place to be. We're not friends today, are we? I do that a lot.
I'm coaching first base today. Really? Yeah.
If you can take it from Brooke, you go ahead.
Yeah. I bet. I don't know how Brooks will feel about that one. I guess it's gonna feel a freaking clinch to this.
All right. What is this? What have we done that looks like this?
An equation.
Congratulations.
Unicircle.
The U minus V. This is U minus V. What's your formula for that? If you look on your cheat sheet. There it is. Sine U minus V down here at the bottom. So sine, what was U? Cosine V. It's a minus. Cosine U was 5 pi over 3, and then sine V pi over 4. All right. Back to your unit circle. 5 pi over 3, but we're doing sine. So find your 5 pi over 3. It's right here. Sine would be which one? Your y coordinate, which is? Pi over 4, find it. Cosine is your x coordinate. What's your x coordinate? Square root of 2 over 2. Go back to 5 pi over 3. What's your x coordinate for that? 1/2. What's your y coordinate for pi over 4? What's your y coordinate for pi over 4? Yeah. Multiply them together. Square root of 3 times the square root of 2 is square root of 6. 2 times 2 is 4. On the other side, 1 times the square root of 2 is Now what do I do? Now what do I do? But it doesn't look like any of these.
That's because you gotta simplify it. Divide by two.
Do I have to?
Yes.
No, I don't. I can use my calculator. So instead of, I would even probably do it from here so that you don't screw it up to this point. Not being ugly, just, you know, the more steps you do, the more chances you have of messing up. So alpha y equals negative square root of 6 minus the square root of 2 over 4 gives me this decimal. Then match it. So start with the first one. Negative square root of 3 minus 1 over 2 square root of 2. What do you notice? It's the same, so that means that's your answer. And again, you can do that decimal stuff from right here. You don't have to simplify it any at all. How would I do this one? I do not have to do a sum or difference formula. I do not have to do a sum or difference formula. Yeah, just put it in the calculator. But what I need to make sure of, degree mode. So mode, degree, sine 345 gives me this crazy decimal. And then how would I figure out which one's my answer? Plug them in. So I'm going to go ahead and tell you that it's C negative square root of 3 plus 1 over 2 square root of 2. There's my decimal. C would be your answer. Again, you would plug them all in. 16, you could use a formula for, or what could you do? Yeah, so cosine 60, cosine 65, minus sine 60, sine 65 gives me this decimal. And then I can go plug these in. Cosine 65. Is that the same decimal?
Oh,
Cosine 125. Yes, that's your answer. Move on.
Could you just do the
Mhm.
cosine plus b
Mhm.
add the 665 and do cosine?
Mhm. You could. But if you're not gonna look on that formula sheet, are they gonna do it? You're gonna be pretty, a lot of them are gonna do it this way and be pretty lazy. The quicker way is the formula sheet. Is that right good? So what she said is this is the same as cosine u plus v or alpha plus beta. So cosine 60 plus 65 is cosine 125. Of course, that's a lot simpler, but how many of you are going to look at that? Not a lot. Absolutely. All right, 17. This is a formula. What do you see? It's 10 minus 10, blah, 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 find it. Did everybody see it? Which one is it? If you don't know how to read this, whatever's on top goes together. So u plus v is tan u plus tan v, 1 minus tan u tan v. So what do we have on the bottom? We have the positive. So what is this one if the positive is on the bottom? Tan what? U minus v. Tan u minus v. What was u? What was v? What's 7x minus x? There you go. How else could I have done it? Yeah, put this into y equals, then put these into y2 and see which one match on the graph. Got it? Do I have to have this one in radian mode? Do I have to have this in radian mode? Do I have any pause? No, so I don't have to. It doesn't matter which one you put it in. All right, look at your next one. Find the exact value of sine u plus v, given that sine u and cosine v are equal to those. Both u and v are in quadrant 2. What does that mean if both u and v are in quadrant 2?
That goes y to the positive one.
negative x, and a positive y. Okay, so a negative positive. What's my formula for sine u plus v?
Sin U cosine V
Mhm,
plus,
mhm.
and then sin
Problem is, I don't know what all of this is, so I need to make a U triangle and a V triangle. How many times did we do this? A lot. Our U was sine. What's your ratio for sine on a triangle? Opposite over hypotenuse. How do I find the other side? So I get 60. Cosine V, I don't worry about the signs. Remember, why is this negative? Because the x coordinate is negative. So I just don't even worry about the signs. What is your triangle ratio for cosine? Adjacent over hypotenuse. Find the other side. I didn't need to do that, but still. And then fill it in. Sine U was already given to you. Cosine of V was already given to you. Sine of V, remember sine is the y coordinate, so it's going to be positive. But what is your sine of your V triangle? 9/41. Cosine of U, your x is going to be negative. For U, what's your ratio for the triangle? For cosine? Adjacent over hypotenuse. Helen. Hey. No. Yep, no. Okay, well, no. All right. Multiply these all together. I'm going to go ahead and tell you that they give you negative 980 over 2501, which is C. The best way to do this is to put them in alpha y equals 11 over 61 like that. And then it will give you the answer in simplest fraction form if you use alpha y equals. Is everybody okay? All right. Find the exact solution on the interval. How do I do that? How do I find exact solutions? You can. So that's going to be a little bit harder because they're both going to be those curves and they're going to kind of overlap. A better way to do it, you can do it that way. That is perfectly fine. Y1 and Y2 is to go ahead and subtract that sine x to make it equal to 0. Now you can do it the other way. This just looks a little easier when you do it like this. So in Y1, we're going to put in sine 2x minus sine x. And then in Y2, we're going to put in 0. I'm going to zoom trig again. Now, what that does, moving that sign over, is it doesn't have like the wave and then a second wave. All it has is one wave and a straight line. So it just makes it a little bit easier. Where do I look for my answers?
Right.
Okay, so second trace intersect. The first one is that. Is it included? Yes. Why did I mark out the A and C? Yep. Second trace intersect. Let's check the next one. What did I get? Why did I get 60? Because I'm in degree mode. So what is the radians for 60? And you can look at your unit circle. What is it? Pi over 3. So we had 0. Now we have pi over 3. So it can't be E because we have more than 1. Second trace intersect. Enter. 180. What is that one? Did I get 2 pi over 3? So your answer is B.
So on the graph, just every time that it with the straight line, you just
Mhm.
see what kind of
Where red and blue meet. Yep, for sure. All right, use the figure below to find the exact value of the given trig expression sine theta over 2. The figure not necessarily to scale, which is fine. So my cheat sheet. Sine, it's just not even on there. Oh, this might be the one that's not on there. These were in your notes. Well, see, this is on me because I should have gave you this. It's a power reducing formula. Remind me on Monday, please remind me, and I'll put those up there. So if you missed 20, it's on me. Dylan, do you have to retake your test if it's an 80?
That should be 100, that's on your old grade. That should be 100.
No, it shouldn't.
Oh, 80 for 100 on your old grade.
Yeah, when you're in the low level classes,
I don't think I love those classes.
I feel
you
like
should be. I'm just
Oh,
kidding, you
that
should
was-
not.
That was. there.
And in a smart.
When he wants to.
Everybody is. Watch your mouth.
Man, you go to church. Go see some Jesus.
Guys, we don't have time for this. So remind me again to put these power reducing formulas up there. If I think about it before we leave, I'll put them up there. All right, so sine theta over 2, these were in your notes. I'm sorry they were not on your cheat sheet. I pulled your cheat sheet straight from your book, so just made a copy of it. So now what would I do? Now that you know the formula. Plus or minus square root. 1 minus. What's this? Okay, what's cosine theta on your triangle? Okay, what do I not have? How do I get the hypotenuse? Okay, what do I do? Mm-hmm. 15 squared plus 8 squared is 289. Square root, and I get. Everybody good? So what's your cosine ratio? Over 2. We're gonna clean it up. I'm gonna just do the inside. 1 minus 15 over 17 over 2 gives me 1 over 17. Remember when we take the square root, we take the square root of the top and the square root of the bottom. What's the square root of 1? I cannot have the square root of 17 on the bottom, so how do I fix it? Which is? See. Right. The next one is on there, cosine 2 theta. It's right here in the double angle formulas. Remember, that's the one you could have a whole bunch of things. I'm going to use 1 minus 2 sine squared theta. You can use either one that you want to. So pick whichever one you want. I'm doing 1 minus 2 sine squared theta. What do I got to do on my triangle then? How do I do it? Tell me. equals 13. So what is your hypotenuse? Square root of 13. So 1 minus 2. What's your sine ratio? Opposite is 2. Hypotenuse is. And we're going to square that. You want to square both parts. 2 squared is 4. Square root of 13 squared is 13. 2 times 4 is 1 turns into 13 over 13 minus 8 over 13 gives you there you go. So my answer is E. That's it. Alright. Same thing on this one. I should have given you this and I didn't. So this is equal to cosine u over 2. So those are those half angle formulas. What will u be? What do you think u is going to be? Say it again. 12x. And what do we get? How else could we have done this? Yeah, put it in your calculator. Everybody good? So we could have put this in y1 and then put your answers in y2 and see which one's graphed over each other. So that one you didn't need the formula for.
Put the equation in Y1.
Mhm.
and then
Okay. So square root of 1 plus cosine 12x over 2. And then put your answers in. So I'm gonna go ahead and do cosine 6x. I'm gonna zoom trig. If they're the same, what should happen? They should overlap each other. What happened here? Why? They're close, aren't they? Let's see the rest of them. We have plenty of time, by the way, so don't stress out. Let them make you graph all these. That was really off, right? Right? We definitely know that was on it. Get that one out. Yeah, just a little bit, right? This one's gonna be fun too.
Why is it flat line?
We definitely know that one's not right. Definitely not. Check out the next one. It's really off, right? So this one and this one are really off. The 6x and 12x were really close. What makes it weird? How many answers are there to a square root? That's the problem. Okay. So why is the 6x better than the 12x? We'll talk about that in just a second. Give it a second to graph again. What is it doing? You see how it's skipping one? Can y'all tell that it's like a red one, then a blue and a red on the top? Red, blue, red, blue, red, blue. Where does that red go?
In between.
It actually just pops negative, right? Well, what's wrong with that? When we're talking about square root, what do we typically have answers on our square root? Positive. We usually use our positive. So that's why that one's messed up. Look at the 12, because we said that was the other one. And tell me the difference in it. So here's that normal, the cosine, the square root. So again, it's a positive square root. I didn't put the negative square root in. That's why it looks weird. What's this one do? It's overlapping all the blue and some. Does everybody understand that? So we don't want that and some. But again, you'll get those half angle formulas, and I'm sorry that I did not put them up.
So it's still B?
Yeah.
Even though that 12 is closer, so.
12 is not closer. It has extra stuff.
If it's extra, that makes sense.
Again, use your half angle. This is your half angle point. This is your answer worked out by hand. I just want you to see what you'll see in the calculator if you want to get the answer based on the calculator. All right, how do we do this? Find all the solutions. I would put it in the calculator. What are we going to do though? What are all our answers in? Yeah, let's make sure we're in radian mode. That's also probably why the other thing looks kind of weird. It might look better if you put it in radian mode. So y equals cosine x over 2 minus sine x, and then a 0. Zoom trig. Don't forget, once we get to 25, we're going back to that 7, 8, and 9. So we still have those two. All right. What am I looking for? Where at then? Past the 0, right? Yeah. All right. Remember, I put it back in radian mode, so I got 1.04. But if I change it back to degree, let's see what happens. Oh, you can't even see it. Don't worry about it. Yeah, that's exactly what it is. So 1.04, we know that that's not pi, right? What is pi? Okay, so what about pi over 3? I'm going to put that in my calculator. What did I get? So I know pi over 3 is one of my answers. So these go away because I don't have pi over 3. Second trace intersect, we're going to look at the next one. It's at 3.14, which is pi. So I know I have a pi, so E has to go away. What's the difference in these two? One has another answer, right? 5 pi over 3. Let's see if that's what this is. So 3.14 and 5.24. So 5 pi over 3 is what? So which one's our answer? See. Any questions? Product to sum formula, it tells you exactly where to look. for 6 sine pi over 10 cosine pi over 10. So product to sum, it is sine cosine. So that's this one. We already have a 6 outside. So we just hang on to it. Your formula tells you to do 1/2. We'll go back to my formula, sine cosine 1/2, and then sine u plus v, sine u minus v. What's our u? Can't really screw this one up because what's our v? Plus sine, and you're subtracting them. Pi over 10 minus pi over 10. What's half of 6? 3. Pi over 10 plus pi over 10 gives you 2 pi over 10 or sine pi over 5. What about right here? Pi over 10 minus pi over 10 is? What is sine of 0? Think about your 0, 2 pi, your degrees, whatever. Go to your y coordinate. What's your y coordinate at 0 degrees? Is everybody good? So this equals 0. So I have 3 sine pi over 5. And my answer is B. Use the sum to product again. It tells you what to do. It says 2 cosine u plus v over 2 sine u minus v over 2. That's what you're doing. All right. So 2 cosine, what's our u? 4 theta, what's our v? Over 2 sine, what's our u? What's our u? Minus our v over 2. We get 2 cosine, what's 4 plus 2? Over 2. 3 theta. 4 minus 2 is? Over 2 is 1 theta or just theta. Which one is your answer? B. That's it. All right, so I'm going to work out 7, 8, 9 right here. You can write them right here. It's perfectly fine. I'm going to write the problem down so you guys can see it. So 7 was secant theta minus sine theta tan theta. Thank you. All right. Which one's the harder side? Yeah. What is secant? Whatever cosine, right? Remember, we want to get it in sines and cosines. It makes it a little bit easier. Here we have a sine that is perfectly fine. Fixed tangent. Okay. When I put these together, leave this one alone, it's fine. What's sine times sine? Since we have a common denominator, I can just squish the top together. So everybody should be okay up until this point. When we look at the top, we have a 1 and some trig function squared. So you should know that that's Pythagorean identity. 1 minus sine squared is, which will be over cosine theta, which gives you cosine theta. You have to have all of that. If you write this and then you give me that, that's not proving anything. That's not proving anything. So don't skip. That's it. Number 8. Let's do number 9 first. Let's do number 9. It's easier than 8. Number 9 is secant squared theta. Tan squared theta minus secant squared theta plus 1. I was impressed with people that got this. You did a great job. All right, what do I do? Obviously, what's the harder side? So right here, what can I rewrite? Everything's in terms of tan, right? Let's put it in terms of tan. How do I fix this? How do I rewrite this in terms of tan? Is it? Check it one more time. Secant squared theta is, so secant is 1 plus tan squared. So this is 1 plus tan squared theta. Guys, I need you to stop talking. Minus, what is secant squared again? We just did it. 1 plus tan squared theta. Again, why am I changing it to that? Everything's in terms of tan. That's what we wanted. We can multiply these out now. Don't try to fix them. Multiply them. What's tan squared times 1? What's tan squared times tan squared? Distribute your negative. So we get -1, negative tan squared theta, and then we have a plus 1 on the end. Is everybody okay with that? What happens? Was that problem hard? No. You guys are making them more complicated than what they are. Okay. All right, number 8. The square root of 1 plus sine theta over 1 minus sine theta equals 1 plus sine theta over cosine theta. Absolute value of cosine theta. Fix this inside. How do I fix a fraction that looks like this? Nope. I don't want the square root. Let's not even look at the square root for just a minute. How do I fix the inside? What do you mean multiply the top by the bottom?
Like multiply both parts by 1 minus 9.
Close. Conjugate. How many times have we done that? Quite a few, right? So the reason that we do that is because we can't separate the top and the bottom. We can't fix it. So this is how we're going to fix it.
How do you know whenever the multiply by the conjugate step like 1 minus 7?
You want to get the bottom to cancel out, period. So I need, how can I get cosine from sine?
Was
What are you going to do the square root in a minute? Square it, right? So if I square these, or if I multiply them together, 1 squared, sine squared, there's my Pythagorean identity. All right, so on the top, I'm just going to squish it together like this, 1 plus sine theta squared. Don't do anything with it, just leave it like that. How do I multiply the bottom? Fronts and backs, 1 times 1. Negative sine times sine. Okay. What does 1 minus sine squared theta turn into? What did I not work with? What happens when you have a square root and a square? So this is the same thing as the square root of 1 plus sine theta squared over the square root of cosine squared theta. Square root and the square cancels out and leaves you with 1 plus. sine theta, and then on the bottom, what happens? Square root in the square cancels out, leaves me with. Why do they put absolute value? Because we want the positive. We don't want the negative. That's all. Is everybody good? Any questions? Any questions? All right.